Every modern city depends on a system that almost never appears in its history books. It works continuously, without attention, and without pause. If it stopped today, the city would become unlivable before nightfall. Waste is a physical constant. It has mass, it occupies volume, and it obeys the laws of thermodynamics. We tend to think of waste as something to be discarded, but physics does not recognize the concept of away. It only recognizes relocation. For most of human history, waste stayed where it was created. Food scraps, animal remains, human excrement, all of it accumulated close to living space. Not by choice, but by physical constraint. Removal was never a cultural preference. It was a mechanical ultimatum. The moment people gathered in numbers, the problem appeared. One household could manage it, 10 households strained, 100 failed. Early cities were not limited by intelligence or ambition. They were limited by their exhaust. This is where cities began to fail. A city is a machine for concentration. To sustain 100,000 people, a pre-industrial city had to import thousands of tons of grain, timber, and livestock every week. That mass did not disappear. Its usefulness did. Physics is unforgiving. What enters a system must also leave it. But it leaves changed. Heavier, wetter, more chemically active. In the language of science, this is entropy. And entropy does not disappear. It accumulates. Inside city walls, the math was brutal. Death rates exceeded birth rates every year. For centuries, ancient and medieval cities survived only because rural migrants continuously replaced the dead. The city functioned as a population sink. People flowed in. Waste could not flow out. The archaeological record preserves this failure clearly. In Rome, in Alexandria, in Jerusalem, excavations reveal thick layers of refuse beneath later streets. Middens stacked on middens. Ground levels rising by centimeters each decade. Cities were not only built on their past, they were slowly buried by it. For thousands of years, waste removal depended entirely on human muscle. Buckets, carts, pits, trenches. The logic was simple. Lift it, carry it, dump it. The system collapsed under its own arithmetic. As cities grew, the distance waste had to travel increased. Each additional meter multiplied labor. Each added worker required food. Each meal generated more waste. This was the caloric barrier. The system consumed more energy trying to clean itself than the city could provide. Some cities tried to solve the problem through commerce. In 18th century London, human waste, night soil, was collected and sold as fertilizer. In Edo period Japan, it was measured, traded, and taxed. But markets obey physics too. Once transport costs exceeded the value of nitrogen, the trade stopped. The flow reversed. The city began to fill. Early engineering solutions followed the same flawed logic as labor. Latrines were dug. Cesspits were lined with stone. Waste was buried, burned, or diluted by rain. Open channels carried runoff during storms. These systems worked until they didn't. They required constant maintenance. Sediment settled. Sludge thickened. Flow slowed. Viscous waste adhered to channel walls, increasing friction. As velocity dropped, solids fell out of suspension. Channels narrowed from the bottom up. Odors rose. Insects multiplied. Effort could delay failure. It could not prevent it. For thousands of years, every solution failed for the same reason. This is where the equation finally changed. The breakthrough came when engineers stopped trying to overpower waste and began to work with gravity. Slope changed everything. Gravity does not tire. It does not forget. It applies force continuously. Once waste was given a permanent downward path away from living space, labor was replaced by flow. The problem shifted from effort to geometry. The Romans understood this with unsettling precision. They did not simply dig ditches. They redirected water beneath the city. The Cloaca Maxima, still partially functioning today, was built as a stone-vaulted hydraulic channel. They lined it with masonry and bonded it using volcanic pozzolana cement, a material that grows stronger when submerged. But flow alone was not enough. What mattered was scouring velocity. If water moved too slowly, turbulence dropped, solids settled. They compacted into dense, concrete-like sludge that choked the channel from the bottom up. If the slope was too steep, the opposite failure occurred. Water accelerated away from the waste, leaving heavy solids stranded to dry and harden against the masonry. The system had a narrow operating window. At roughly 0.6 to 0.9 meters per second, water carried just enough energy to lift particles and keep them tumbling forward. This was equilibrium. The difference between drainage and infrastructure. This was the moment cities stopped drowning in themselves. Waste stopped being handled everywhere. It was guided once. Covered drains replaced open filth. Waste disappeared underground, not because people found it offensive, but because visibility was no longer necessary. Once waste entered the system, the city no longer interacted with it. London learned this lesson the hard way. By the mid-19th century, the Thames had become an open sewer. Warm, slow-moving water mixed with concentrated human waste. Anaerobic bacteria thrived, releasing hydrogen sulfide and methane. The result was chemical, not moral. In the summer of 1858, the smell became unbearable. The Great Stink. Curtains in the House of Parliament were soaked in chloride of lime just to allow debate to continue. But the deeper revelation came earlier. In 1854, physician John Snow mapped a cluster of cholera deaths around a single water pump on Broad Street. He did not see bad air. He did not see a curse. He saw geometry. A leaking cesspit was seeping into a nearby well. The city was a closed loop. The output of the home had become the input of the kitchen. The sewer and the water supply were not separate systems. They were one. Joseph Bazalgette understood the implication. Out of sight, he warned, is not enough. He rebuilt London's metabolism, more than 1,300 miles of sewers, over 300 million bricks, embankments raised, rivers redirected. One rule governed everything. Waste must move one way. Forever. Even perfect slopes required isolation. Until the 19th century, sewers were two-way systems. Waste flowed away, but gas flowed back. The atmosphere of decay shared the air of the home. The invention of the S-bend changed that. A small volume of standing water formed a gas-tight seal. That curve of water beneath every toilet isn't plumbing trivia. It's the reason decay stopped sharing our air. The human respiratory system was finally separated from its own output. Two worlds emerged. Above, air, light, movement. Below, masonry, water, gravity. This separation made height possible. Without sealed vertical waste removal, the high-rise cannot exist. Every additional floor increases pressure on the pipes below. Every connection is a calculation. Cities grew upward because waste could fall downward. But every solution made one quiet assumption: that gravity would always work. Modern systems did not eliminate friction. They changed its chemistry. In today's sewers, fats, oils, and greases cool and solidify. They react with calcium in concrete, forming waxy compounds that adhere to pipe walls, fatbergs. They destroy hydraulic gradients by increasing friction until flow stalls. To remove them, engineers return underground. Pressurized suits, high-pressure jets, manual labor. Even now, gravity must be defended, and gravity itself is no longer stable. In Mexico City, the ground sinks by up to 50 centimeters a year. Built on a drained lake bed, the city subsides faster than its pipes can adjust. Slopes reverse. Waste must be pumped uphill. Passive systems become active. Electricity replaces geology, and electricity is not guaranteed. If the power fails, the system fails. And when the system fails, cities fill within hours. Today, waste leaves your home without ceremony. It enters a network you will never see. It flows, settles, accelerates, slows. It is processed, diluted, released. The system does not pause. It does not announce itself. Civilization is not a monument. It is a process. If intake stops, we starve. If output stops, we choke. The sewer is not a convenience. It is a condition. The systems that matter most rarely demand attention. They work quietly, continuously, out of sight. They shape our lives not by what they provide, but by what they remove. We live above a second city, masonry, gravity, flow. And as long as its gradient holds, the world above remains stable. Because when these systems fail, cities don't collapse dramatically. They suffocate.